Okay, I'm going to do all of these odd problems right here, even though they're not all part of your problem set. Okay, so 27. It says, postulate 1-4 states that any three non-collinear points lie on exactly one plane. And so there's always a flat surface that you could lay down that would run through any 3 points in space. And if they're non-collinear, it's going to be a unique line. And we'll talk about what if it is collinear, what does that look like? Okay, now find the plane that contains the first 3 points listed, and then determine whether the fourth point is in that plane and write coplanar or non-coplanar. So what we're looking at for number 27 is these three, z, s, and y. That's z, s, and y. And as you can see then, what those points, where those points are is this, that plane right there. Okay, is C also in it? Yeah, it is right there. Okay, so find the plane, determine whether the fourth point is on that plane. It is, and so we would say the terminology we would use is that these are coplanar, meaning they're all on the same plane. Okay, and let's do it for number 29. We have x, y, z. Let's find those. X, y, z. And then they also name u. And by the way, what is that plane for x, y, z? That plane for x, y, z, that's also that same plane going running right here. That was in the last one. Okay. Now, is u on there? Nope, u's not on there. That's on a different plane. And so since it's on a different plane from those, we would say that that is non-coplanar, meaning they're not, all 4 points are not all on a single unique plane. Okay? And then finally, the last one, we look at the first 3 points, determine what plane contains x, z, and s, x, z, and s. And as you can see, that's also continues to be that same plane in yellow there. Okay? And what about v? Well, v is landing over here, not on that plane. And so we're going to, once again, have to call it non-coplanar, meaning not landing on the same plane that the other 3 points, the first 3 points define. So that's how you do it.